Hi everyone. Today we are going to learn about correlation, chapter 3 correlation. By the end of this topic, students will be able to define the dependent and independent variable, draw and explain the scatter plot, calculate the correlation coefficient using Pearson method. Okay, so the first subtopic we have here is in example 3. Table 3.1, dependent and independent variable. So we need to identify the behavior of a single variable, and then we need to know which one depends on the other. We need to explore the variable separately using graphical tabulation or numerical measure, but then first of all, we need to know within the exploration of this variable, what is the relationship between the variable. So we have dependent and independent variable rationally related to each other, and then we need to classify dependent. In this chapter, dependent is y, independent variable is x, variable x. So the dependent variable we interested to predict or estimate. So we interested to predict or estimate variable y. And then variable y is being influenced by the independent variable. So, as we can say, our total profit is directly related to total sale. So we need to explore the relationship between these two variables. That's what we call as correlation between two variables. So for example, your telephone bills depends on the call usage that you have called your friend maybe 60 hours in a month. So your phone bill are going to increase depends on the usage, not the other way around. So we can say that our dependent variable is telephone bills, and then it is being influenced by independent variable, which is call usage. To study the correlation between two variables, we call it as correlation analysis. So the correlation analysis actually measures the strength of a linear relationship between dependent variable y and independent variable x. And then we can use it to identify whether there is a strong, weak, moderate, or no relationship between variables. So the first method that we have here is graphical display or scatter plot. So for scatter plot, we need to draw y against the corresponding value of independent variable x. So we need to draw, in this case this is y-axis and then this is x-axis, and then after we plot the dots in the graph, we can see that there is a pattern in the graph. It is increasing. In this first scatter plot, we decided that it is actually have a positive relationship between variable x and y. And then for scatter plot in B, we have x and y axis. So you can see the pattern is downward, so decrease. So as x increase, the value of y will be decrease. So this situation we consider it to be negatively related. For graph C, we can see here the pattern is not linear. So we are not going to cover this in this chapter. And D, the pattern is also non-linear. So we are not going to cover this in this chapter. And then the last one, there is no pattern at all. In this case, we consider it to be no relationship. So we are going to cover on the three types of relationship in this subtopic. First, positive, negative, and then the last one, no relationship. The second method to calculate the correlation between two variables is using Pearson product moment method. So for the computational method, we need to calculate the value of correlation coefficient. Correlation coefficient, we consider it as R. This is the correlation coefficient. So we have the formula here. The formula is actually not that hard. We only need to find the cumulative between x multiplied with y, and then cumulative x multiplied with cumulative y, and then the same thing we need to repeat down here. And n is actually the number of pair observation. X is independent variable, y is dependent variable. And then after you calculate the value, we are going to get the value for R is the lower should be 0 or the higher would be 1. So let's say if you get the value R equals to 1, we need to give a comment or interpretation of the relationship is actually there is a perfect positive relationship between X and Y. Or if you get your value, R value in between 0.8 and 1, we consider it to be strong positive. But then if you have the negative value, we are going to consider it as strong negative. 0.5, 0.8, it is moderate positive. If you have the negative, it's going to be negative relationship. And then less than 0.5, we are going to consider it as weak positive relationship, or if it is negative, it is weak negative relationship. And then R equals to 0, it means that there is no relationship between X and Y. So you need to remember how to comment on the value of the correlation coefficient. So next we're going to discuss about the example of using this formula. Okay, so this is example 3.3. A study conducted to determine whether the selling price of a used car can be estimated using its age. The following table depicts the data distribution of 8 random selected used car. So we have n equals to 8, so pair variable. Age 7 years, the selling price 15,000. So if you use the car until 12 years, maybe you are going to sell it at 9,000. So this is the example of the data. And then first, A, state the dependent and independent variable. So the dependent variable is Y, independent variable is X. So logically, selling price is Y, and then X is the age of the car. Your selling price depends on the age of the car. If you use the car longer, like 10 years, 12 years, your selling price would be lower. So this actually means that selling price depends on the age of the car. So this is the answer. And then B, plot a scatter diagram and comment on the relationship between selling price and the age. So since we already decided which one is Y, which one is X variable, so the selling price is Y variable, the age is X variable. So you just need to look at the value. Age equals to 7, the selling price is 15. So age may be somewhere right here, 7. So the value would be 15. So this is your dot. So you need to plot all the values here. 10, 13. So 10, 13 somewhere here. So this is the dot. So after you draw everything, so this is your scatter plot. So this is quite easy. So like we have discussed about this, the relationship, if you want to comment on the relationship based on the graph, so you look at this graph, you can see that there is a pattern, downward pattern. So we can say that this is a negative linear relationship between selling price and used car, which means that the longer you use the car, the price are going to be lower. For question C, calculate the correlation coefficient using Pearson product moment method and explain its meaning. So correlation coefficient, it is actually R. So we need to go to the solution. So the data that is given by the question is actually variable X and Y only. So if you remember about the formula just now, in order to calculate R, the formula is summation xy minus summation x multiply summation y divided by n. And then you need to divide by square root summation x square minus summation x, and then you need to square the value inside the bracket, and then you need to multiply with summation y square minus summation y in the bracket square divided by n. So you need to calculate, first of all, you need to calculate all the values that you have. Okay, so this one is, you total up everything at the end of this column, you're going to get summation of x. And then for y, you total up everything at the end of this column, you're going to get summation y. So you already have this value and this value. So you need to calculate summation x square. So for 49, this is actually 7 square equals to 49. And then you total up everything, all the values, you're going to get 608. So you have this value. And then for y 225, this is actually 15 square. So you're going to get 225. So you calculate for everything, you total up everything, you're going to get summation of y. So n is actually the number of paired observations. So n equals to 8. You just need to calculate how many pair you have here. 1, 2, 3, 4, 5, 6, 7, 8. So the value is 8. So you already have the n. And then you need the summation of xy. So in order for you to calculate the summation of xy, you need to add another column where x is multiplied by y. So 7 multiplied by 15, you are going to get 105. So this one 10 multiplied by 13, so you're going to get 130. So you total up all the values, you're going to get 8801 for this one. So after you calculate everything, you just need to substitute all the values into the formula that we have, and then you need to use your calculator, and after you calculate it, you are going to get the value negative 0.9368. So the symbol negative here is actually means that there exists a strong negative linear relationship between selling price and age. How do you know it is strong? You need to refer to the previous table. So R, if the value of R falls in between 0.8, or for this one we have negative value, negative 0.8 less equals to 1, this is actually strong relationship. So that's why we consider that in the comment there is a strong negative linear relationship between selling price, this is the y, the dependent variable, and age in years, this is x, independent variable. So after you calculate, you need to comment on the value. So that's it. We already answered all questions. Thank you.